Hello everyone. Welcome back to a new tutorial. In today's video, we're going to explore another feature of Arduino programming, the external interrupt. We're going to explore how we can use it to create a simple project of incrementing a number on an LCD display with the Arduino Uno. So, grab your Arduino and let's dive in. Before we jump into the project, let's understand what an external interrupt is. As we all know, the Arduino has two main functions, the void setup and the void loop. Every time the Arduino is turned on, the configuration commands in the void setup function are executed, and then the commands in the void loop function are executed indefinitely. In other words, in an infinite loop. An external interrupt is a feature that enables an external event to interrupt the normal execution of an Arduino's program. Once the external signal is triggered, the execution of the void loop function is interrupted and an interrupt service routine, known as ISR, is executed instead. After the interrupt routine is executed, the execution of the void loop restarts from where it is stopped. The Arduino Uno has two external interrupt pins, marked as int0 on digital pin 2 and int1 on digital pin 3. These pins can be configured to trigger an interrupt service routine when a specified event occurs. In the context of Arduino, the external signal could be generated from a sensor, a button press, or any external event that requires the immediate attention of the microcontroller. An important aspect of the interrupt service routine is how it is triggered. There are three main possibilities that we are going to explore during the code development. An interruption could be triggered by a rising change on the pin, which means that the signal on the pin needs to change from low to high. It can also be triggered by a falling change on the pin, which means that the signal on the pin goes from high to low. And a third possibility is to trigger the interruption just by a signal change on the pin, which means that the signal on the pin can go from high to low or from low to high to trigger the interruption. All three possibilities will be explored during the code development. Now, let's jump to our circuit assembly. We are going to use the Arduino Uno board, the LCD display, model PCF8574, with address 32. And we have a small breadboard with a push button and a resistor of 220 ohms. I have already made the power connections of 5 volts and ground on the breadboard. And I also powered up the LCD display on the breadboard. If you need details regarding the LCD pin connections we are using, just click on the card that is on the top of the screen to watch a tutorial that I made about it. Let's connect the SDA pin from the LCD on the SDA pin of Arduino and the SCL pin of the LCD on the SCL pin. Now we are going to make the connections for the push button. We are going to use the pull-up configuration. If you need more details about this configuration, just click on the card at the top of the screen to learn about it. In this configuration, the resistor terminal goes to the ground. One terminal of the push button goes to 5 volts. And the other terminal goes to pin number 2 because that is the pin we are going to configure as external interruption. In this configuration, when the button is not pushed, we are sending 0 volts to the pin, and when it is pushed, we are sending 5 volts to the pin. Let's also add a multimeter to measure the voltage on the interrupt pin during the simulation. Now, let's jump to our code. We are going to start by adding the LCD libraries. We need to add the wire and liquid crystal libraries. Then, we can create two integer variables. The button pin that is going to represent the interrupt pin, which is number 2. And a variable called number that represents the number to be shown in the display. It starts with value 0. Regarding the LCD display, we are going to use the command liquid crystal to configure the LCD by inserting the address, which is 32 in Tinkercad. then the number of columns of the display, which is 16, and finally, the number of rows, which is 2. The rest of the configuration of the LCD we are going to do in the void setup. We are going to start with the command LCD init to initialize the display. Then, we are going to turn on the backlight by using the command LCD backlight. And we are also going to print a text, which is the text number. Notice that the text we are printing has a total of 7 characters, including the colon character. After that, we are going to define that pin number 2 is an input because that is the pin that we are going to use as interrupt. So we need to use the command pin mode, and the first argument is the pin that we are going to configure, which is the button pin. And we are configuring it as input. And the last command in the void setup is the command that is going to configure the interruption itself. So we are going to add the command attach interrupt, and this command has 3 arguments. The first argument is a reference to the interrupt pin that we are going to use. To find this reference, we need to use another command which is called digital pin to interrupt, and its argument is the pin number that we are going to use as interruption. So we're going to put button pin. The second argument is the name of the routine that is going to be executed when the interruption is activated. As we are going to use the interruption to increment a number, we are going to call the routine as increment number. And the third argument is how the interrupt will be activated. For now, we're going to use the rising signal to activate the interruption. In the void loop, we are going to set the cursor to the 8th character. Because the number that we are printing here, it has already 7 characters. And we are going to print the number, which is initially 0. And the last step is to create the interrupt routine, which is going to be called increment number. And every time we activate the interruption, we are going to increment the variable number by doing that. And that's it. So basically, what we are doing in our code is, we are importing the 2 libraries that control and configure the LCD display. Then we create a variable that has the pin number that we are using, and another variable that is going to store the number that we are incrementing. Then, we initialize the LCD display. In the void setup, we are initializing the LCD, and we are turning on the backlight and printing the text number on the display. Here, we are configuring the pin number 2 as input, and we are configuring the interrupt routine for pin number 2. In the void loop, we are printing the variable number in the 8th column of the LCD display, and every time the interruption is activated, the execution of the void loop is interrupted. Then we go to the interrupt routine increment number, and we are going to increment the number. And once it finishes, we are printing an updated number, which is going to appear in our display. Okay, let's now simulate our code. As you can see here, we are sending 0 volts to the interrupt pin, and we are printing the initialized variable number, which is 0. If I press the button, I'm going to send a rising signal because the signal goes from 0 to 5, and then we increment the variable number. And every time I click the button, I can increase the value on the display. Let's try a different thing now. If we go back to our code, and if I change the mode to falling and restart our simulation, we are going to see that when I press the button, the display is not going to increment because I generated a rising signal from 0 to 5. Right now, I am holding the button, but once I release it, we are going from 5 to 0 volts, which is a falling signal. Because of that, we are going to generate the interrupt signal, and then the display will increment. I'm going to release the button now, and we can see that it was incremented. So that's why we have different options to generate the interruption. The first one was a rising signal. And now it's a falling signal. So when I press it again and hold it, I just generated a rising signal, and then, once I release it, I generated a falling signal, and it increments again. However, if I go back to the code and just put change on the mode, it's supposed to generate an interruption every time I generate a change in my signal, whether it's rising or falling. Let's try that. So, once I press it, I generated a rising signal, so I generated an interrupt, and then the number incremented. And after I release it, I also generated a second interruption with a falling signal. Basically, by using the change mode with a single press on the button, I am going to increment my display twice because I'm generating a rising signal And also a falling signal, one after the other, with a single button press. There you have it. We've explored external interrupts and applied them to a practical project using the Arduino. I hope you found this tutorial informative and helpful. If you have any questions or ideas for future tutorials, drop them in the comments below. Remember to like this video, subscribe for more Arduino goodness, and happy tinkering.